All right, let's get right to it. We're tackling a massive question that pretty much every company has to answer. Where should your data live? Because, let's be real, it's your most valuable asset. Today, we're putting Amazon's cloud powerhouse, Redshift, in a head-to-head battle with the traditional do-it-yourself on-premises data warehouse.
You know, the best way to think about this is like deciding where you're going to live. Do you want to build your own house from the ground up? I mean, you'd get to pick every single nail, every paint color, every fixture. Total control. That's your on-premises solution. Or do you rent a sleek, modern apartment in a high-tech building where the landlord takes care of all the plumbing, the security, the maintenance? That, right there, is the cloud model with Amazon Redshift.
So here's how we're going to break down this whole build versus rent thing. We'll start with the absolute basics, the fundamental divide. Then we'll get into the nitty-gritty of architecture and scalability, how these things are built and how they grow. We'll look at performance, the true cost, and I mean the real cost, and then we'll tackle management, security, and who's really in charge. By the end, you'll know exactly what to think about when making your choice.
Okay, first things first. Section 1, the fundamental divide. Before we can really compare these two approaches, we've got to make sure we're all on the same page about what a data warehouse actually is and what it does.
So think of a data warehouse as the central nervous system for a company's intelligence. It's this one central place that pulls in all the raw data from everywhere, from sales, from marketing, you name it. It then cleans it, organizes it, and turns it into something actually useful. It's what lets your analysts spot trends and get those game-changing insights. It basically becomes the company's single source of truth, so everyone is singing from the same hymn sheet.
And that brings us right back to our analogy. With on-premises, you're the homeowner. You buy the servers, you hire the people to install the software, you manage the network, you pay the power bill to keep it cool. It's all on you. With Redshift, you're the renter. You pay AWS a monthly fee, and they handle all the headaches. They own the building, they fix the leaks, they upgrade the security. So we know what they are. Now let's talk about how they're actually put together. This is where we get into architecture and scalability. And trust me, the way these systems are designed has a huge impact on how they perform and, more importantly, how they can grow when your business explodes.
Okay, this is a really big deal. In the old-school on-prem world, compute, so the processing power, and storage, the space for your data, are basically handcuffed together. If you need more storage, you're forced to buy more compute, even if you don't need it. It's super inefficient. But modern cloud warehouses like Redshift have completely decoupled them. You can add more storage without touching your compute, or crank up the compute power for a busy day without adding any storage. It's all about flexibility. And this flexibility is powered by some seriously cool tech. First, there's massively parallel processing, or MPP. Imagine you have a giant 10,000-piece puzzle. Instead of one person doing it, MPP gives a small chunk of the puzzle to hundreds of people to solve all at once. It just demolishes huge jobs. Then there's Columnar Storage. See, old databases store data in rows. To find one piece of information, they have to read the whole row. Columnar Storage is way smarter for analytics. It only reads the specific column it needs, which is ridiculously faster. And all this leads to that last point: you can add or remove those puzzle solvers whenever you want.
And here's where you really feel the difference. Scaling an on-prem system? We're talking a massive undertaking. You've got to plan, get budget approval, order hardware, wait for it to arrive, install it. It can take months. With Redshift, it's elastic. Let's say it's Black Friday and your website is getting hammered. You can literally jump into the AWS console, click a few buttons, and add more horsepower in minutes. And then, when things calm down, you scale it right back down so you're not paying for what you don't need.
All right, we have established that Redshift is flexible. But is it actually fast? That's the million-dollar question, right? This brings us to performance and speed. When you're running a critical report with your boss looking over your shoulder, which one delivers the goods faster?
Redshift's speed isn't just one thing. It's a whole bag of tricks. It uses incredibly fast solid-state drives for its local storage, but it also does some clever stuff with software. It actually compiles your queries down to the computer's native language, which makes them run super efficiently. And then there's Aqua, the advanced query accelerator. You can think of Aqua as a special, hardware-powered fast lane for your data that can make some queries up to 10 times faster. It's a real game changer.
But, and this is really important to know, there's a trade-off. Research from MIT pointed this out. Redshift is kind of like a Formula One race car. It is unbelievably fast once it gets going on the track. But first, you got to get it out of the garage and warm up the engine. That warm-up for Redshift is loading data from its long-term storage in S3 onto those super-fast local drives.
That can take a few minutes. So for sustained, heavy-duty analytics, it's a beast. But for a quick one-off query, there's a little bit of a startup lag.
Speed is great, but what's it going to cost me? Let's get to the topic everybody's waiting for, the true cost. And we're not just talking about the sticker price here. We're going to look at the total cost of ownership, what you're really going to pay over the long haul.
Now, this table really tells the story. An on-prem setup is all about capital expense, or CapEx. That's a huge upfront investment in hardware and software. But the real killer is all the hidden costs, the salaries for the expert staff you need to run it, the massive electricity bills for power and cooling, the cost and hassle of every single upgrade. Redshift flips that completely on its head. It's an operational expense, or OpEx. There's no big upfront cost. It's just a predictable monthly bill that includes everything: the hardware, the staff, the power, the upgrades. It's the difference between buying a house and just paying your utility bill.
And the difference can be absolutely mind-blowing. According to a study done by TE Systems for AWS, the savings can be as high as 97.5% compared to on-prem. I mean, just let that sink in. That's a number that makes any executive sit up and pay attention.
Okay, so cost is a huge point for Redshift, but what about control? That brings us to our next big area: management, security, and control. This is really about who's in the driver's seat, who's responsible for maintenance, for protecting the data, and for overall governance.
Let's talk about a worst-case scenario, a crisis. Your on-prem data center has a major failure. Well, guess what? Disaster recovery is 100% on you. That means you had to have already built and paid for an entirely separate redundant data center just sitting there waiting for something bad to happen. With Redshift, disaster recovery is just built in. AWS can automatically copy your data to a totally different part of the world, so if one region goes down, you're covered.
And that managed advantage covers so much more. All the software patches and upgrades, AWS handles them for you automatically. Backups, they happen automatically. And security is a huge one. Redshift comes with encryption built in, and it's certified for all sorts of strict compliance standards. I mean, think about it. Amazon hires legions of the world's best security experts. Most companies could never afford to match that level of protection on their own.
But here's the main argument for on-prem: absolute total control. You own the hardware, you control the software, you know the exact physical spot on the planet where your data lives. For certain highly regulated industries, this can be a non-negotiable requirement. With Redshift, it's what we call managed control. You still control who has access to your data, but you're trusting AWS to manage the underlying infrastructure. It's a shift in mindset for sure.
So that brings us to the final section, making your choice. We've gone through the architecture, the speed, the cost, and the control. Now let's tie it all together and figure out which one of these is the right fit for you.
So when does it still make sense to build your own house? Well, there are a few key scenarios. If you work in an industry where you need absolute granular control over every piece of hardware and software, on-prem could be for you. Same goes if you have really strict data sovereignty laws that say your data cannot leave a building that you physically own. And of course, if you've already invested millions in your own data centers, it might make sense to stick with it.
But for almost everyone else, Redshift makes a really compelling argument. If cost is a major factor and you love the pay-as-you-go model, it's a no-brainer. If your business has unpredictable peaks and you need to scale in minutes, not months, Redshift is your answer. And if you'd rather have your smartest people finding insights in the data instead of patching servers and managing backups, then the cloud is definitely the way to go.
And you can see this happening everywhere. This diagram shows the common path companies are taking. They're modernizing. They are actively moving their data out of those old, clunky on-premises systems and into cloud platforms like Redshift. It's a clear trend.
But I want to leave you with one last thing to chew on. We've been talking about this as a simple cloud versus on-prem decision. But what if that whole debate is changing? With new services like AWS Outposts, you can now run actual AWS hardware inside your own data center. So maybe the real question for the future isn't cloud or on-prem, but how you can best use cloud and on-prem together. What do you think?